From this equation, let's now define an important quantity, the impulse of a force. Multiplying both sides of the equation by delta t gives us force times delta t equals the change in momentum. The impulse of the force is defined as the force multiplied by the time elapsed during the impact of the force. Thus, the impulse is just the change in momentum. We all know why people wear protective helmets and pads, but why do these simple devices work so well at preventing injuries? Let's take a look at the concepts of momentum and impulse and see if we can determine the answer. We can graphically represent the impulse or change in momentum by a rectangle of sides f and delta t. The area of the rectangle is a measure of the change in momentum. This representation illustrates the fact that, for a given change in momentum, the force of impact can be very large, when the time of impact is very small. On the other hand, if the time of impact is increased for a given change in momentum, the force of impact decreases to keep the product F delta T constant. Cushions, bumpers, and pads used in everyday life use this principle to protect against shocks by increasing the duration of impacts. Let's work through an example. A 1 metric ton car, traveling at 72 kilometers per hour, strikes a concrete wall and comes to a full stop in 0.1 seconds. What is the average force of impact exerted on the car? First, let's calculate the change in the car's momentum to determine the impulse due to the collision. Subtract the initial momentum from the final momentum. Since the final velocity of the car is 0, the change in momentum is given by the mass of the car in kilograms multiplied by its initial velocity in meters per second. Notice that the velocity has a minus sign because it is directed in a negative direction in our system of coordinates. The average force exerted on the automobile is given by the change in momentum divided by the duration of the impact. Let's see what happens when we increase the time of impact by placing large foam pads in front of the wall. This time, the duration of impact is 2 seconds. What is the magnitude of the average force of impact now? Impact lasts 20 times longer than the initial impact, while the change in momentum remains the same. The resulting force is 20 times weaker. Now we know the answer to our original question. Protective pads act to increase the time of impact, thereby decreasing the force of impact. With a smaller force of impact, the chance of injury is reduced.